Hello. It's okay. So yeah guys, so we were discussing about there are some ground rules that you should be knowing about the session. The first ground rule is if I am audible, visible, slides are visible. That means what? Technically it is sounding great, so you will be typing yo in the chat box. If you have understood the topic, there is no doubts, no difficulties, then you will be typing V in the chat box. Okay, and last but not the least, if to appreciate someone who participate in question answer round, we will be typing CC in the chat box. CC stands for clap clap in the chat box. Clear? Sure. So let's get started from wherever we have stopped. The next question of the NCERT, okay, I have already discussed some of the questions of NCERT before. Now let us discuss some of the other questions. The next question that comes is, what do you mean by hydroboration oxidation? The question is this: what do you mean by hydroboration oxidation reaction? And the same thing you have to explain with the help of a example. Okay, first of all, hydroboration oxidation, we give this thing shortcut as HBO. Hydroboration oxidation. Okay, clear? Next thing. The next thing, if I talk about its reagent. The hydroboration oxidation reaction, the reagent is, you can use B2H6. The first step is to use B2H6, that is hydroboration reaction. B2H6, or what you can use is BH3 in THF. Okay, so this is the first step. Second step for this particular reaction is addition of peroxide, that is the oxidation reaction in the presence of base. In the presence of what? Base. So these are the reagent that need to be used. Then next, what are the pointers that you have to remember? Okay, point to remember. Okay, so the first point, it follows anti-Markovnikov's rule. It follows what? Anti-Markovnikov's rule. That means addition of water will take place in such a way that the negative part of the water will go to carbon containing more number of hydrogen. And since it follows anti-Markovnikov's rule, okay, alkane 1-ol, or basically 1 degree or max to max 2 degree alcohol formation is preferred. Okay, 1 degree alcohol or 2 degree alcohol formation is preferred, and to be very specific, 1 degree alcohol. Okay, when the alkene is terminal alkenes, the major compound is 1 degree alcohol, and when alkene is a non-terminal alkene, 2 degree alcohol will be preferred. Clear? Sure. So yeah, these are some of the pointers that you have to remember. Now, how to remember the reaction? So talking about the reaction goes in this way. See, I am giving you general reaction over here. You take an alkene, R, CH, double bond, CH2. Okay, R, CH, double bond, CH2, and this has been treated with first BH3 in THF or B2H6. Okay, so the compound, okay, if you take 1 mole of it, the compound, so if you take 1 mole of an alkene, the compound that has been formed is this. R CH2 CH2 BH2 if you take 1 mole, but ideally we take 3 moles. Okay, so the entire stuff, this will become 3 times, and we can easily erase this thing. Okay, clear? Then followed by addition of peroxide and base. You will get R CH2 CH2 OH, that is nothing but 1 degree alcohol. That is nothing but what? 1 degree alcohol. Clear? Sure. So how many moles of alcohol has been found? 3 moles. How many moles of alcohol has been found? 3 moles plus this will be the product. Okay. So now if you will see how Markovnikov's rule has been followed, shortcut if I wanted to show you. Okay, shortcut. Take water H, wait a sec, HOH, partial negative and partial positive, right? And according to anti-Markovnikov's rule, negative part to carbon containing more number of hydrogen. So carbon containing more number of hydrogen, so it will get added over there. Got it? Clear? Any doubts, any difficulties? Anyone? Any one of you guys? Any doubts, any difficulties to any one of you? Any doubts, any difficulties? No one? Perfect, great. Clear guys? Sure. So that was the simply explanation of what hydroboration oxidation reaction. Let us discuss this thing with the help of an example. So for example, what I am going to take is, let us take CH3 CH double bond CH2, that is propene. Okay, so when propene is been treated with BH3 in THF followed by base and peroxide, followed by base and peroxide. Clear? Then finally you will get product as, you have to take, I am taking as BH3, so I am taking it 3 moles, right? So you will get 3 moles of CH3 CH2 OH, 3 moles of this thing plus B OH thrice. Clear? Sure. Got it? Perfect. So this is wait, I have not marked the product properly. It was 3 carbon atom, right? So we need to mark a 3 carbon atom product. So it is 3 moles of CH3 CH2 CH2 OH. This is propane 1-ol. Clear? Got it? Sure. So that was the first question. Just make a note of it. Just make a note of one thing. If you use B2H6, then then 6 moles of alkene, is required. Okay, and 6 moles of alcohol has been formed. Clear? Sure. Any doubts, any difficulties to any one of you? Any doubts, any difficulties to any one of you? No one? Perfect. Great. So that was the first question. If you'll see, what do you meant by hydroboration oxidation reaction, and we have illustrated this thing with the help of an example. Okay. Next, give the structures and IUPAC name of monohydric phenols. Very important, monohydric phenols with molecular formula C7H8O. So here first I will be discussing with the help of what? The molecular formula, and the question that is and the answer that has been expected from all of you is what? Monohydric phenols, right? तो पहले तो हम यही डिस्कस करेंगे कि इस पर्टिकुलर मॉलिक्यूलर फॉर्मूला से मोनोहाइड्रिक फिनॉल्स कैसे बन सकते हैं, एंड देन उसके बाद और कौन से हम फिनॉल्स या और कौन से हम आइसोमर्स बना सकते हैं, दैट वी आर गोइंग टू सी. रानी, बोर्ड इज नॉट सीन, व्हाई सो? बोर्ड एग्जैक्टली व्हाट? कैन यू जस्ट टेल मी दिस थिंग, एग्जैक्टली व्हाट? Rani, am I like you are able to see me? Are you able to see me? And board is not visible? You are able to see me, but board is not visible. How can that is possible? Board is simply over here. Rani, not visible? Okay. Fine. Now it is visible. Just check. Writing is not visible. Okay, chalo, let's see, let us try something. If it is again not visible, just let me know. I hope now you should see it. I have done some adjustment. So give the structure and IUPAC name of monohydric phenols with this molecular formula. Okay, since they have given it as phenol, so let us start. C7H8O. It is a very good practice. Okay, it is a very good practice to identify degree of unsaturation. So let us mark degree of unsaturation first. So degree of unsaturation, if you will see, it is half, twice of carbon. So twice of carbon is 14 plus 2 minus the monovalent atom, that is 8. Oxygen can be neglected because it is divalent. Okay, so it is 16 minus 8, that is 8. 8 by 2 is 4. So obviously there is only one benzene ring, because benzene ring degree of unsaturation is 4. Okay, now Once we know the degree of unsaturation, what we need to mark is phenol. So this should be compulsory present. This should be present compulsorily. Okay. For phenol, what is the molecular formula? C6H6O, and this is C6H6O. What is needed is what? C7H8O. Okay. What is needed is what? C7H8O. So what is remaining over here? CH2. Okay. C6H5. Yeah. So only thing that can be done is over here CH3. Right. Remove one hydrogen, add one methyl group, so it will give you what? It will give you what? C7H8O. Like see, 1 carbon, 2 carbon, 3, 4, 5, 6, 7. There are 7 carbon atoms, 1 hydrogen, 2 hydrogen, 3, 4, 7, 8. Okay. Clear? Okay, so yeah, this is a concept, right? So this is one of the isomer that can be formed. Which is this isomer? It is ortho isomer. It is what? An ortho isomer. Clear? It is an ortho isomer. Similarly, can you draw meta? Can you draw para? Yes, so there are 3 isomers that are possible. So this is meta, and then the last one is so these are the isomers that can be prepared. Okay, these are the isomers that can be prepared. Anyone, any doubts, any difficulties? Anyone, any doubts, any difficulties? No? Now, what are the another, okay, what are the another compound that we can prepare from this thing? Okay, there are certainly 1 or 2 other compounds that can be prepared, but yes, here the question was that is fixated on monohydric phenols only, so that's why I have drawn monohydric phenols. Okay, clear? But certainly we can draw some more compounds with the same molecular formula. Certainly we can draw some more compounds with the same molecular formula. Let us see. C7H8O, one of the molecular formula that can be formed is this, or one of the compound, and that is anisole. If you want, you can calculate, it is C7H8O. Okay, you can calculate this thing. Second, benzyl alcohol is also possible. Again, you can calculate the you can calculate the molecular formula over here. You can tally the molecular formula, you will feel the same thing. Clear? Sure? Mani, are you there? Rani, are you there? Rani, are you there? I hope now you are, I hope I am now audible, visible, and even whatever I am writing, that is also visible, right? Anyone can confirm me in the chat box? Anyone can confirm me in the chat box? Any one of you? Okay. Any one of you can confirm in the chat box. So yes, these are the compounds that can be discussed, that can be formed. But yes, in examination the question was pretty much simple, monohydric phenols. That's why the answer is 3 and not 5. But yes, this is something I've given you a extra information. This is something I gave you in what? Extra information for this. Clear? Done? Sure. So yeah, next, while separating a mixture of ortho and para nitrophenols, okay, ortho and para nitrophenol, again an important concept that we are going to dig a bit deeper. By steam distillation, obviously the name of the isomer which will be steam volatile, the name of the what we say, the name of the isomer which will be steam volatile. What is that exactly? Let us understand. So see, ortho and para nitrophenol. First of all, let us draw the structure ortho and para nitrophenol. So this is ortho nitrophenol, right? Next one, para nitrophenol. ओके, ऑर्थो नाइट्रोफिनॉल एंड पैरा नाइट्रोफिनॉल. अब एग्जैक्टली क्या होता है जिसके वजह से एक का बॉइलिंग पॉइंट ज़्यादा है, एक का बॉइलिंग पॉइंट कम है? उसका रीज़न बहुत सिंपल है, वो स्ट्रक्चर को थोड़ा सा ध्यान से एनालाइज करना. हम सबको पता है वाटर का स्ट्रक्चर कैसा होता है, बेंट शेप होता है, समथिंग लाइक दिस, राइट? कैन आई से दिस फिनॉल स्ट्रक्चर इज ऑल्सो फॉर्म ऑफ वाटर जिसमें एक हाइड्रोजन इज रिप्लेस बाय वन बेंजीन रिंग, राइट? सो उसके हिसाब से इफ आई ड्रॉ द स्ट्रक्चर, कैन आई ड्रॉ H एज लाइक दिस एंगल्ड? एक्चुअली इसका स्ट्रक्चर ऐसे ही होता है, देयर इज एन एंगल बिटवीन देम. ओके, सो बिकॉज ऑफ दिस थिंग व्हाट हैपेंस इज दिस इज नोन एज इंट्रामॉलिक्यूलर हाइड्रोजन बॉन्डिंग. इंट्रामॉलिक्यूलर हाइड्रोजन बॉन्डिंग. ओके, क्लियर? सो ये क्या होता है? इंट्रामॉलिक्यूलर हाइड्रोजन बॉन्डिंग है. सो इंट्रामॉलिक्यूलर हाइड्रोजन बॉन्डिंग इज प्रेजेंट इन ऑर्थो नाइट्रोफिनॉल. किसमें प्रेजेंट है? ऑर्थो नाइट्रोफिनॉल. whereas if I talk about para nitrophenol, if I talk about para nitrophenol, in para nitrophenol what has been present is intermolecular hydrogen bonding. What has been present is what? Intermolecular hydrogen bonding. Clear? Now, in this, since intramolecular hydrogen bonding is present, wait, that is, yeah. In this thing, since intramolecular hydrogen bonding is present, so can I say that since intramolecular hydrogen bonding is present, it will lag in intermolecular hydrogen bonding? Means what? It won't do hydrogen bonding with another orthonitrophenol which is present there. And since since the hydrogen bonding between two orthonitrophenol decreases, or the hydrogen bonding is less as compared to para nitrophenol, can we say that their intermolecular force of attraction is decreasing? And since their intermolecular force of attraction is decreasing, can we say that their boiling point will decrease, right? And that is the reason why orthonitrophenol is steam volatile. इज व्हाट? स्टीम वॉलेटाइल. तो मैंने क्या क्या पॉइंट बोले? फर्स्ट ऑफ ऑल, यहाँ पे क्या हो रहा है? इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग हो रहा है, मतलब मॉलिक्यूल के अंदर ही क्या हो गया? हाइड्रोजन बॉन्डिंग हो गया. और अगर मॉलिक्यूल के अंदर हाइड्रोजन बॉन्डिंग हो गया तो एक ऑर्थोनाइट्रोफिनॉल दूसरे ऑर्थोनाइट्रोफिनॉल से हाइड्रोजन बॉन्डिंग नहीं कर पाएगा. एंड सिंस वो उसके साथ हाइड्रोजन बॉन्डिंग नहीं कर पाएगा, so द फोर्स ऑफ अट्रैक्शन दैट माइट बी प्रेजेंट इज वैन डर वाल्स फोर्स ऑफ अट्रैक्शन, जिसके वजह से उसका बॉइलिंग पॉइंट, उसका इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन कम होगा. एंड सिंस इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन डिक्रीजेस, देयर बॉइलिंग पॉइंट विल डिक्रीज. Because what is boiling point? It is first breaking the intermolecular force of attraction and then converting a liquid into a gaseous state. Okay? यहाँ पे पैरानाइट्रोफिनॉल के साथ क्या हो रहा है? There is no intramolecular. there is intermolecular hydrogen bonding, मतलब ये जो मॉलिक्यूल है वो दूसरे पैरानाइट्रोफिनॉल के साथ एक अच्छा स्ट्रॉन्ग हाइड्रोजन बॉन्डिंग बनाएगा. So whenever you start heating it, that energy is first consumed to break that hydrogen bonding, and after that hydrogen bonding is broken, then liquid will get converted to what? Gaseous state. And that is the reason, okay, that is the reason why paranitrophenol has what? More boiling point as compared to orthonitrophenol. Clear? Sure. Second चीज इसके बारे में जो आप लोगों को और याद रखना है, due to this intramolecular hydrogen bonding, its acidic strength decreases. Please make a note of it. If I talk about acidic strength, okay, para is more acidic than ortho. Very important line of very important things. Okay. Ideally, ortho should be more acidic. Okay, but since this hydrogen, this acidic hydrogen over here is involved in hydrogen bonding, whereas this acidic hydrogen over here is free, that means what? This can be easily donated. This can be easily donated, and since it can be easily donated, its acidic strength increases and its acidic strength decreases. Clear? This is an extra point. It is not a part of a question. Part of the question I have already discussed. But yes, this is something that you should know. Clear? Sure. Now, if I ask you guys one question, out of orthonitrophenol and paranitrophenol, which is volatile? Can anyone answer me this thing? Which is volatile? Any one of you? Which is volatile? Orthonitrophenol or paranitrophenol? Any one of you can give me the answer? Any one of you who can give me the answer? Guys, any one of you who can give me the answer? Out of orthonitrophenol and paranitrophenol, which one is volatile? The answer is orthonitrophenol. If I talk about volatility, this will be more volatile than paranitrophenol. Clear? Any doubts, any difficulties? Any doubts, any difficulties to any one of you? Any one of you out there, any doubts, any difficulties? No one? Sure? Perfect. Talking about the next question. Give the equations of reaction for the preparation of phenol to cumene. First of all, there is something that you should know. Cumene. Cumene is a common name of isopropyl benzene, is also known as cumene. First thing. Second, preparation of phenol from cumene is also known as industrial / commercial method of preparation. It is also known as industrial / commercial method of preparation. Okay, that means this has been used, this particular reaction has been used to prepare phenol in a large scale. Okay, we'll explore the reason as well why it is used in industry for the preparation of phenol. First of all, let us see the reaction. First, what happens is, here isopropyl benzene is oxidized. Okay, so how this oxidation takes place? First of all, let us prepare isopropyl benzene. So this is isopropyl benzene. Okay, so this isopropyl benzene is been oxidized in the presence of oxygen. So you have to use air or oxygen directly, and the temperature is around 130 degrees Celsius if my knowledge serves me right. Okay, something around this thing. Isopropyl benzene is oxidized to peroxide. It has been oxidized to peroxide. That means this hydrogen bond will look like this: C O O H. And let us draw the another structures, the part of it. Okay, so this is what cumene or isopropyl benzene. This is known as cumene hydroperoxide. This is known as what? Oh, sorry, it is not, it is peroxide. Okay, it is what? Cumene hydroperoxide. Finally, it is hydrolyzed. Finally, it is hydrolyzed. Okay, and you will get the compound as finally it will get hydrolyzed to a compound known as what? Phenol. It will get hydrolyzed to a compound known as what? Phenol plus CH3 C double bond O CH3, that is acetone. That is simply what? Acetone. And yes, you should not forget this thing, acetone. Okay, if I simply talk about this acetone, it is a very good industrial solvent. Please make a note of it. So here this is one of the reaction in chemistry that we study is the product and the byproduct. They both are very important. Okay, they both are pretty much important, and that's why this particular reaction is used to prepare phenol from cumene, and that's why this is also a reason why it has been adapted by industrial. Okay, so in industry also most of the industries prepare phenol by this particular reaction, because the byproduct that we are getting is also what? A important stuff or an important solvent as an industry point of view. Okay, clear? So yeah, this is the equations of reactions for the preparation of phenol from cumene. Anyone has any doubts? Anyone has any doubts? Anything? Any one of you? No one? Sure? Perfect. So next one, write a chemical reaction for the preparation of phenol from chlorobenzene. Okay, preparation of phenol from chlorobenzene. Okay, here you will use Douse process. What process we are going to use is Douse process. So let me mark that process, Douse process. Now what is the Douse process? Douse process is a reaction in which chlorobenzene it is a reaction in which chlorobenzene is treated with sodium hydroxide. It is treated with what? Sodium hydroxide, or basically it has been fused with sodium hydroxide at 613 Kelvin, at 613 Kelvin. Okay, so that is a particular temperature at very high pressure. Okay, when chlorobenzene is treated with base at 613 Kelvin at a very high pressure, it will give you first sodium phenoxide. First, it will give you what? Sodium phenoxide. This is sodium phenoxide. Please make a note of it. Okay, so when chlorobenzene is treated with base at 613 Kelvin at high pressure, you will get sodium phenoxide, and after that you have to do hydrolysis. After that, what you have to do is hydrolysis of it, acid hydrolysis, and the moment you do acid hydrolysis, you will get phenol. Okay, you will get what? Phenol. Okay, so this is a particular reaction in which phenol can be prepared from chlorobenzene or basically halobenzene. Clear? Any doubts, any difficulties to any one of you? Any doubts, any difficulties to any one of you? No one? So with this thing, if anyone has any questions to ask, I am open for the questions now. Please go ahead and ask your questions, whether it's related to NEET or whether it is related to today's concept or whatever it is. Any doubts, any difficulties will be entertained. Any one of you, any questions? Any one of you, any questions to any one of you? Make it quick. I assume that you are writing. If you have any doubts, any difficulties, please let me know in the chat box. Make it quick. Any doubts, guys? Any one of you? Can I have thumbs up in the chat box that everything is okay? We can end the session today, guys. Guys, done? Chalo then. With this thing, thank you so very much for joining this session. God bless you all. Let's connect in the next. I'll definitely expect you all to do register for my next session as well. Make one thing pretty much important, that you are going to set the reminder for that particular chapters or that particular sessions as well. With this thing, guys, thank you so very much for joining this session. God bless you all. Take care. Keep smiling. We'll meet soon. Take care, guys.